Something is breathing on Mars. At least, that is what the measurements seem to say. On the floor of Gale Crater, a rover repeatedly sampled the cold Martian night and found tiny pulses of methane. Then another spacecraft, carrying one of the most sensitive atmospheric instruments ever sent to another planet, searched for the same gas from orbit. It found nothing. The contradiction did not disappear after better measurements. It became stronger. This is not a story about proving life exists on Mars. It is the story of why one of the planet's most intriguing signals refuses to behave the way science expects. The investigation begins with something almost invisible. Methane is a trace gas. On Earth, it can come from living organisms, but it can also emerge through entirely geological processes. Simply detecting methane says nothing about its source. Even so, finding it on Mars immediately captured attention, because the planet was expected to possess very little of it. The rover exploring Gale Crater carries an instrument designed for exactly this challenge. Inside its analytical laboratory, a laser beam reflects back and forth through a sealed chamber before measuring how much light methane molecules absorb. That long optical path allows the instrument to detect extraordinarily small concentrations of gas drawn directly from the Martian atmosphere. Night after night, it sampled the air. Most of the time, the atmosphere contained only a faint background amount. The measurements drifted through seasonal changes, remaining around a fraction of a part per billion. Then, without warning, everything changed. On several occasions, methane concentrations climbed dramatically, reaching nearly 20 parts per billion, before falling away again. The gas had appeared. Just as importantly, it had disappeared. The first mystery was no longer whether methane existed. It clearly did. The real question became, what could possibly be releasing it? At first glance, the answer seems straightforward. Methane does not automatically mean biology. Natural geological processes can produce it without any living organisms at all. Deep underground reactions between rock and water can generate methane. Ancient deposits might slowly release trapped gas. Even frozen reservoirs could potentially leak under changing environmental conditions. Those possibilities sounded reassuring because they required nothing extraordinary. Mars could simply be behaving like another rocky planet. But every proposed explanation encountered the same obstacle. The methane was not behaving consistently. Instead of remaining steady, it arrived in sudden bursts. The background level shifted with the seasons. The spikes appeared briefly and then vanished. A geological source might explain methane. It did not explain all of the observations. The investigation refused to close. Attention slowly shifted away from what was creating the methane and toward something even stranger. Perhaps the measurements themselves were wrong. That possibility seemed reasonable. After all, one rover was sampling air from a single crater on a planet with a global atmosphere. If methane truly survived for hundreds of years, as standard atmospheric chemistry predicted, planetary wind should gradually spread it around Mars. Eventually, every sensitive instrument should find it. A new spacecraft arrived. The European Trace Gas Orbiter was built specifically to study gases like methane. Instead of collecting air directly, it watched sunlight pass through the edge of Mars's atmosphere. The atmosphere itself became part of the measuring instrument. Any methane present high above the planet should leave unmistakable fingerprints in the incoming light. The spacecraft searched again and again. Its instruments were capable of detecting methane at concentrations far below what the rover had measured. The result was astonishing. No methane. Not above the detection threshold. Not across the globe. Nothing that matched what the rover had repeatedly found near the surface. The investigation had entered entirely different territory. It became tempting to assume one of the instruments had failed. But both research teams carefully re-examined their calibrations. Both sets of measurements survived intense scientific scrutiny. The rover continued detecting localized methane. The orbiter continued finding none in the upper atmosphere. The contradiction no longer belonged to the instruments. It belonged to Mars. The invisible gas had returned. But now it represented conflicting evidence rather than a possible discovery. If both observations were correct, then something about the Martian atmosphere itself was missing from existing understanding. Researchers began looking less at methane's source and more at the environment through which it traveled. That search led to the thin layer of air hugging the surface. Mars changes dramatically between day and night. After sunset, the ground cools rapidly. The air closest to the surface becomes calmer and more stable. During daylight, sunlight heats the ground, stirring the atmosphere into vigorous vertical mixing. Those changing conditions suggested an intriguing possibility. The rover almost always performs these atmospheric measurements during the cold Martian night, when its instrument operates under stable thermal conditions. The orbiter observes the atmosphere using sunlight during dawn and dusk, looking through layers several kilometers above the ground. Dust prevents it from directly examining the lowest few kilometers where the rover lives. Suddenly, the two instruments were no longer observing exactly the same atmosphere. Imagine a faint seep of methane escaping from the ground during the quiet hours of night. The gas could accumulate close to the surface inside Gale Crater while the air remained still. Hours later, daytime heating would stir the atmosphere, diluting that pocket until it became effectively invisible from orbit. The idea was elegant. It explained why the rover might detect localized methane while the orbiter did not. For a moment, the mystery appeared to be dissolving. Another contradiction emerged. Even if methane hides near the ground for part of each day, it cannot hide forever. Standard atmospheric chemistry predicts that methane should survive for roughly 300 years before sunlight gradually destroys it. Over that enormous span of time, countless daily cycles should eventually spread methane throughout the planet's atmosphere. The orbiter should still find evidence of it somewhere. It does not. Something else must be happening. Perhaps methane is being destroyed far more rapidly near the surface than current chemistry predicts. Researchers have proposed several possibilities. Electrically charged sand grains created during wind-driven abrasion might accelerate chemical reactions. Highly reactive compounds in Martian soil could remove methane much faster than expected. Other unknown surface processes may be consuming the gas before it ever escapes into the wider atmosphere. Each proposal explains part of the evidence. None explains everything. The invisible methane returns one final time. At the beginning, it looked like a clue pointing toward whatever lay beneath the Martian surface. Now it represents something very different. It marks the boundary between what scientists can measure and what they still cannot fully explain. The rover continues to detect localized methane in Gale Crater. The orbiter continues to report an atmosphere remarkably free of methane above it. Neither observation cancels the other. Together, they reveal a planet whose atmosphere still behaves in ways that challenge established models. The search for methane began as a hunt for a possible source. It became an investigation into an entire planetary system that refuses to fit comfortably inside our expectations. The signal remains invisible. The contradiction remains real. And on Mars, that unresolved contradiction has become one of the strongest pieces of evidence that the planet still holds fundamental secrets waiting to be understood.